For f of x equals negative 4x plus 1, what is the output for the given input? Now, this is not multiple choice. We're going to go through each one of these and input each one of these into that function, starting with negative 2. So for f of x equals negative 4x plus 1, if our input is negative 2, the output would be taking negative 4 times negative 2. It's a positive 8 plus 1. The output is 9. So the input is negative 2 and the output is 9. In other words, if you graphed that function, this point, negative 2, 9, where x is negative 2, y is 9, that point would be on the graph of that function. Do the same thing for 0. If we input 0 into that function, we're finding f of 0. So we're replacing the x with 0, taking negative 4 times 0, that is 0. 0 plus 1 would be 1. So when we input 0, the output is 1. Or in other words, the point 0, 1 would lie on the graph of that function. For 5, if we input 5 in, take negative 4 times 5, or we're finding f of 5. Negative 4 times 5 is negative 20. Take negative 20 plus 1, that would be negative 19. So when we input 5, the output is negative 19. Or in other words, 5, negative 19 would lie on the graph of that function. For the function f of x equals negative 4x minus 3, which of the following is f of negative 2? So which of these answers is f of negative 2? In other words, when you substitute negative 2 in for x, which of these will be the output? So if you replace the x with negative 2, take negative 4 times negative 2, watch your signs, it's a positive 8. That would be 8 minus 3, and that is positive 5. So when the input is negative 2, the output is positive 5, which is letter C. Evaluate each function for the given value of x and write the input x and the output f of x as an ordered pair. So when we're done here, we're going to take the x coordinate and the y coordinate, write them as an ordered pair. F of x equals the negative of 2x plus 1 over 3, for x equals negative 5. So we're going to take that function and replace the x with this negative 5, or we're inputting negative 5. We want to see what the output is. So you're taking the negative of, watch your signs there, the negative of 2 times negative 5 plus 1 over 3. We'll do the 2 times negative 5 first. It's going to be negative 10. So we still have the negative of negative 10 plus 1 over 3. In the numerator, negative 10 plus 1, that would be negative 9. So we have negative 9 over 3, but we're still taking the negative of that. Remember, two negative signs back to back will make a positive. So the negative of negative 9 over 3 will turn out to be a positive 3. We need to write that as an ordered pair with this negative 5. So the x value is negative 5, the y value is 3. Negative 5, 3 would be that ordered pair. Next, f of x equals 2/9 x minus 9/2 for x equals 9. Nothing like fractions for breakfast in the morning. Substitute 9 in for x. So you're replacing the x with that 9. We're going to be taking 2/9 times 9 minus 9/2. Put the calculator down. It'll be all right. When you're multiplying fractions, 2/9 times 9, that 9 is really 9 over 1. What you can do when you're multiplying fractions is cancel diagonally. So imagine that 9 over 1. You can cancel diagonally with that other 9. So those 9s will cancel. 2/9 times 9, yes, I see you got it on your calculator. I told you to put it down. 2/9 times 9 is 2. So we're looking at 2 minus 9/2. Don't need your calculator for this either. Just get a common denominator. 2 is the same thing as 4/2. So how I did that, remember, imagine that 2 over 1. Multiply the top and bottom by 2 so that you get the same denominator. So that 2 turns into 4/2. 4/2 minus 9/2, that would be negative 5/2. Or when we input 9 in for x, the output is negative 5/2, sorry. So 9, negative 5/2 would be the ordered pair. To model a situation using a function rule, you need to identify the dependent and the independent quantities. One way to describe or think about dependence of a variable quantity is to use a phrase such as distance is a function of time, which it is. This means the distance depends on the time. Think about that. If you take off running, your distance that you run depends on the time you put in. If you don't put any time in, you're not going anywhere. You're not going to gain any distance, but the more time you put in, the more distance you gain. So your distance depends on, it's the dependent variable, your distance depends on the time you put in. The time is the independent variable. It can be whatever you want it to be. You can sit there and not go anywhere, or you can put time in running and gain distance. So your distance depends on the time. Good times with word problems. Tickets to a concert are available for $35 plus a handling fee of $2.50. Now that the handling fee is going to be the same no matter whether you buy one ticket or 500 tickets, the handling fee will be the same. The total cost is a function of the number of tickets bought. What function rule models the concert tickets and evaluate the function for tickets? So we need to create what's called a function rule to model this situation. So you have to decide what's the independent variable, what's the independent quantity, and what's the dependent quantity. Well, your cost depends on the number of tickets you buy. So cost is the dependent quantity. The number of tickets you buy is the independent quantity. You might buy one ticket or you might buy 500 tickets. If you buy one ticket, the cost is going to be a lot lower than if you buy 500 tickets. So your cost depends on the number of tickets bought. For this particular one, I'm going to let t equal the number of tickets. You can use whatever variable you want. And then since we're talking about cost, C of t will be the total cost. So C of t is the dependent variable. T is the independent variable. Remember that independent variable can be whatever it wants to be or whatever you want it to be. You're buying the tickets, are you buying 1 or 500? But the cost is going to depend on that. So for this situation, what we're looking at is the total cost is equal to the price per ticket times the number of tickets plus that handling fee. We need to write a function rule representing this or showing this. Well, the tickets are $35 each, so we could say 35 times t plus that handling fee of $2.50. That's going to be equal to this C of t. The cost is equal to 35 times t plus 250 or 2.5. So if we were to evaluate that for 4 tickets or figure out what that cost would be for 4 tickets, we'd be finding C of 4. So to find C of 4, you replace the t with 4. You're buying 4 tickets. So take 35 times 4 plus that 250. 35 times 4 is 140 plus the 250. That would be a total cost of $142.50. Enjoy the show. So, how was the show? A phone store employee earns a salary of $450 per week plus 10% commission on her weekly sales. What does commission mean? 10% commission on her weekly sales. She gets 10% of the amount she brings in from selling those phones. So let's say she sells $500 worth of phones. She gets 10% of that. So 10% of $500 would be $50 she would make just for selling that $500 worth of phones. She gets 10% of her weekly sales. Part A, what function rule models the employee's weekly earnings? And part B, if the employee earned $570 in a week, what was the amount of her sales for that week? So part A, what function rule models the employee's weekly earnings? To create a function rule, you have to decide what's the independent quantity and what's the dependent quantity. What is independent in this situation? If she's in a store selling phones, what's independent? The amount of phones that she sells. Because she might sell 1 phone in a week, or she might sell 1,000 phones in a week. That's independent. Nobody knows what it's going to be. The dependent quantity is her paycheck. That paycheck depends on how many phones she sells. Because she's getting 10% commission on her weekly sales, that's going to determine how much her paycheck is. Now this $450, what that is, she's going to get that no matter what. That's her weekly salary. So she might sit around drinking coffee all day and not sell any phones. She's still going to get the $450 paycheck. She might not be drinking coffee for long because she won't have a job, but she'll still get the $450 if she stays there a week. So that $450 plus the 10% commission, that is her paycheck. So back to independent quantity, dependent quantity. The independent quantity is the amount of money she brings in selling phones or the amount of phones that she sells. The dependent quantity is the paycheck. or her weekly earnings. So sales is the independent quantity, weekly earnings is the dependent quantity. I'm going to start by letting T equal the weekly sales. No reason why we're choosing T. You can use X, Y, Z, S for sales if you want to. That doesn't matter. But I'll say T is the weekly sales. That's the independent quantity. Nobody knows what that's going to be. But the dependent quantity, the weekly earnings, since that's T, I'm going to say that's F of T. So F of T will be the weekly earnings. Her weekly earnings depend on her weekly sales. Now, as a function rule here, remember, she's getting $450 plus 10% commission on the sales. So we want to take 10% of T, or 10.1 times T, and add $450 onto it. So again, what's going on here is this $450 that she gets, no matter what, added on to the 10% commission, or 0.1 times T, that's her paycheck. F of T is her weekly earnings. Now it says if the part B now, if the employee earned $570 in a week, what was the amount of her sales for that week? So that $570 is the weekly earnings. That's not going in for T. That's going in for F of T. That's the weekly earnings. So put 570 in for F of T. That's the output. We want to figure out the input. We want to figure out what was her sales that produced that output. So 570 equals 450 plus 0.1 T. Just solve that for T, easy enough. Subtract 450 from each side. Get 120 equals 0.1 T. And then divide each side by 0.1. T equals 1,200. Doesn't mean she sold 1,200 phones. She brought in $1,200 selling phones. So the amount of sales that she made for the week is $1,200.